What's going on, everybody? Miss Berry here. Again, still talking about domain and range when we talk about our piecewise functions, and domain is our x values, range is our y values. So we're taking a look at this graph right here. We should notice a couple different things here. It looks like there's 1, 2, 3 separate pieces going on here. So when we talk about domain and range, we want to make sure that we take into account all of those separate pieces. We know that we see a couple, again, if it was geometry class, rays, I suppose. We have a point that is excluded. We have a point right here that's included, and that excluded one especially is going to be a pretty big deal in this particular problem. So again, let me go ahead and check out the domain and range. I'll start off with the domain. I'm going to grab my ruler here. And again, if you have something at home, it could be like a book or a notebook or something if you're doing a problem, just to be able to extend past the actual picture to make you, remember that we're going to go off in all these different directions. This graph just doesn't stop right here, especially with these arrows pointing in those directions. So when we're talking about domain and range, and when we're talking about domain specifically, I'm talking about my x values here. So I want to consider, as I move from left to right, would there be any points, or would there be not any points, I guess, at a specific location on our x-axis, which I have up here as my ruler. So again, I'm going to move from left to right, and there's nothing right here, no doubt about it, but we can see that this line, this ray, I suppose, would extend forever and forever and forever off to the left. Right, this arrow lets us know it goes forever and ever off to the left, and this arrow lets us know that this is going to go forever and ever off to the right. So when I'm talking about domain here, I do have an arrow going all the way over. About to put 8. It's supposed to be negative infinity. All right, and over here, this arrow leads us going all the way to the right. So I'm going to call that positive infinity. Within the middle of the picture now, I have to kind of pay attention to what's going on with the x values. And this is a little bit easier to kind of eyeball on the graph. So again, here, do I have an x value? Sure, there's an x value. And I keep on going. The only spot on this graph here that's an issue when it comes to the x values is right here, because if I look above that star, there's nothing there. If I look below that star, there's nothing there except for this excluded value. So because we have this excluded value there, and there's nothing above that excluded value, there's nothing below that excluded value, that's a pretty big deal. If I move to the right of that excluded value, there's a point, and a point, and a point, point, and point, and point. We can keep on going, and it extends to positive infinity. The only spot here that hurts us really when we're talking about the domain is the fact that we're not allowed to have a point right there. There is no point on this piecewise function at this spot. And when it comes to our x values here, that x value would be negative 3. So we're going to go off to positive infinity. We're going to go off to negative infinity. The only thing that we cannot have is an x value of negative 3. Everything else here is available to us. We could have an x value of 100 or negative 5. All right, but I can't have an x value here of negative 3. There is no point on this graph that would have an x value of negative 3. When it comes to the range, it's a little bit different of a story. When it comes to the range, again, we're looking up and down on our graph, and we're trying to figure out what about the y values. So again, now I'm going to take my ruler and put it on the y-axis here. All right. And how do I extend upwards? How do I extend downwards? Are there arrows? And these arrows are going to help me out here. Again, when it goes to upwards, this arrow right here, sure, it's pointing off to the right, but it's also pointing upwards. So this line right here is going to extend past our graph all the way up as much as possible. So we will have a positive infinity for our y values. Let's go ahead and check out now our y-axis, and we'll look below here and see how about going down. And again, this arrow we knew already was going off to the left forever and ever, but it's also going down forever and ever. So if it would extend, it would cover forever going downwards. because we have that arrow extending in that direction, we know we're going to have a negative infinity when it comes to our range. Now let's go ahead and take a closer look on the inside here. We had that hiccup when it came to the domain where we knew x was not going to be equal to -3 because of that spot right there. Let's go ahead and take a look. And again, I got the extension up and down. I have a point here, 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 here. The only spot on this graph that could potentially cause us some harm is this spot right here. We're talking about the range, the y value here. This point would be -3, -2. All right, so when we did domain, there was no other spots that had an x value of -3. Are there any spots that have a y value of -2? Well, we take a look here at the graph, and we have this spot right here has a y value of -2. This one has a y -2. This one has a y -2. Y -2, y -2, y -2. So here, when we're taking a look at the range, the y value of -2 has plenty of points. Sure, it has that one excluded one, but there's plenty of points here that take care of our y's. So no matter where I go on this graph, all the way up towards the middle, in this situation, all the way down, I will have at least 1 point in those spots. So when it comes to the range, we're able to go from -infinity all the way to positive infinity. Again, we want to make sure that we have our arrows there when we're doing our inequality notion. -infinity less than y, because we're talking about ranges, less than positive infinity.